Imagine a boardroom high above Santiago. An executive sits at a polished mahogany table. He represents a $4 billion investment, a massive, hard-won stake in a desert salt flat. He expects power. He expects a controlling voice. Instead, he gets a polite smile and a locked door. The local partners do not call the military. They do not seize his company's shares. They simply open a regulatory rule book. They merge the mining operation with the state-owned Titan. They quietly bypass a shareholder vote. They deploy local antitrust restrictions. Overnight, a global financial powerhouse is reduced to a helpless bystander. They are trapped in a joint venture. They cannot see the corporate data. They cannot veto the future. It is a quiet surgical strike, a $4 billion hostage situation executed entirely on paper. Why does the government do this? Why leave the foreign money untouched but strip away all the control? It forces us to look at a strange shift in how the world works. The age of armed soldiers storming mine shafts is over. We've entered a new era, resource nationalism 2.0. Today, countries weaponize environmental audits. They use lease expirations. They use financial commissions to capture wealth without ever touching a shovel. They declare legal sovereignty over the soil. But there is a ghost in this machine, a deep systemic paradox hiding in the paperwork. Rewriting the law is easy, trapping foreign capital is easy, but actually extracting the wealth, that requires a massive native industrial base. It requires engineering, it requires metallurgy. You have to know how to crack the rock. What happens when a nation declares absolute ownership over a resource, but lacks the machinery to pull it from the earth? The legal victory doesn't create wealth, it creates a freeze. The asset simply rots in the ground, buried under a mountain of international litigation.
Right, so we are really looking at this fundamental divergence in the very architecture of global commerce right now.
Yeah, totally.
Because on one side of the ledger, you have, the absolute right of a nation state to rewrite its mining codes, to basically annul private concessions and declare that the minerals beneath its soil are the exclusive property of the nation.
Which they are totally legally allowed to do.
Exactly. But then on the other side of that exact same ledger, you have the unforgiving reality of industrial capacity. And well, this is what we call the sovereignty capacity paradox.
The sovereignty capacity paradox.
The legal jurisdiction over subsoil wealth has become completely decoupled from the structural, financial, and engineering capacity required to actually pull that wealth from the ground and then process it.
So, the whole paradigm of resource nationalism has fundamentally transformed, right? It's moved from a physical act to basically an administrative one. Because if you look back at, say, the mid-20th century, resource nationalism was highly visible. It was military expropriation.
Right, the classic image.
A government would literally send armed personnel to physically seize an oil derrick or a copper mine, tear down the corporate flag, and, raise the national flag. It was blunt.
Very blunt.
But what we are analyzing today is entirely different. It is this complex system of legalistic capture. It's executed with compliance audits, tax code revisions, and corporate restructuring decrees.
And this shift has really established a new ironclad axiom for global economics, which is that the geopolitical and economic return on resource nationalism is strictly bounded by the host country's native industrial base.
Right.
If a state lacks that domestic base, if it lacks the chemical engineers, the high voltage transmission lines, the localized credit markets, its institutional assertiveness doesn't actually lead to wealth capture.
It just leads to a freeze.
It inevitably degenerates into structural paralysis. It leads to asset degradation. The state and the investors just end up trapped in protracted international litigation, and the raw material simply remains in the dirt.
Okay, so before we analyze the specific mechanics of how nations like Chile, Mexico, or Uganda are executing this, and we will get into those, we have to define the exact nature of the resources at the center of this new nationalism.
Yeah, that context is crucial.
Because we are not talking about traditional bulk commodities like iron ore or thermal coal, where the extraction and processing pathways have been, commoditized for a century. We are looking at a landscape of critical minerals where the demand projections are incredibly steep.
Oh, the numbers are staggering.
Right. Between 2025 and 2040, the global demand for lithium, cobalt, nickel, and graphite is projected to double. And in some specific industrial applications, it's expected to quintuple.
Quintuple, yeah.
And this is just a violent upward trajectory driven by non-negotiable end uses. We're talking energy, defense, and high technology manufacturing.
And if you look at the energy sector, the requirements are pushing the physical limits of global extraction capacity. Take copper, for instance. Copper is the foundational building block for electricity transmission. But as the global economy transitions into the era of massive artificial intelligence data centers, the demand profile changes entirely.
Right, because of the power draw?
These cutting-edge hyperscalers, the massive server farms training the next generation of large language models, they generate immense amounts of heat.
Oh, yeah, they run incredibly hot.
So they require extreme thermal solutions to cool the electronics, alongside immense localized power grids just to feed the processors.
So what does that look like in terms of raw copper demand?
Well, by the year 2030, it's estimated that 375,000 tons of copper will be required annually just to service the construction of new data centers alone.
Just for new data centers?
Just for the new ones.
I mean, that number is really difficult to contextualize. 375,000 tons of copper is basically the entire annual output of a Tier 1 mega mine. And that would be a mega mine entirely dedicated just to cooling and powering AI servers. And that is just one specific application for one mineral.
Right.
When you shift the analysis to modern statecraft and defense, I mean, the precision required is even more acute. We are looking at materials that literally dictate the operational capabilities of a military on the battlefield.
Yeah, let's talk about defense, because this is where the anxiety really spikes for governments.
So you have titanium alloys, right, which are absolutely essential for the airframes of fifth-generation stealth fighters.
Because of the heat friction.
They provide an unprecedented strength-to-weight ratio while withstanding extreme aerodynamic friction temperatures. And then you have antimony, which is a critical component in night vision technology and armor-piercing munitions.
And germanium.
Right, germanium, which is required for the lenses in advanced thermal imaging systems.
The concept of a single point of failure within these defense supply chains is, well, it's highly concerning for sovereign governments. I mean, consider samarium.
Samarium, that's a rare earth, right?
Yeah, it's a heavy rare earth element that is virtually irreplaceable when it comes to manufacturing the specialized magnets used in precision guidance systems for cruise missiles and advanced space applications.
So you can't just sub in something else if you run out.
The chemical properties are entirely unique, and the economic modeling around a potential supply shock for samarium is highly revealing. A disruption in the samarium supply chain would not just delay a single defense procurement program. It is estimated that a sustained disruption could cost a single national economy, such as the United States, roughly $4.5 billion in gross domestic product.
Wow. Over one element.
Over one element. Because the ripple effects stall aerospace manufacturing, satellite deployment, and defense contracting across the board, the margins of error for securing these specific elements are functionally zero.
But I want to push on that for a second, because it seems like the real choke point isn't just having the samarium or the titanium in the ground. I mean, the sheer complexity of the metallurgy becomes overwhelmingly visible when we look at, say, the semiconductor industry. We tend to think of silicon as the baseline for computer chips, right? But advanced microelectronics require an entirely different, incredibly complex level of chemical engineering. Look at a material like gallium nitride.
Yeah, gallium's a perfect example, because gallium itself is typically a byproduct of zinc and aluminum processing. It's not really something you usually mine directly.
You don't just dig a gallium mine.
Right, you don't.
Yeah.
But when metallurgical engineers synthesize raw gallium with nitrogen to create gallium nitride, they create a semiconductor material with a significantly wider band gap than traditional silicon.
Okay, so for you listening, think of the band gap as the energy required to make a material conduct electricity.
Yep.
A wider band gap means the microelectronics can operate at significantly higher frequencies, they can handle massive voltages without short-circuiting, and they can power on and off much more quickly without generating catastrophic heat.
And this specific molecular architecture is foundational for advanced radio communication devices, military-grade radar, high-frequency satellites, and the LiDAR systems utilized in autonomous vehicles.
Right.
You cannot achieve these technological functions with standard silicon. You need the specific processed chemical compound.
And the rare earth elements are injected directly into the physical manufacturing process of the chips themselves. I'm thinking specifically of cerium here.
Yeah, cerium oxide. Cerium oxide slurries are utilized in a highly specialized manufacturing process called chemical mechanical planarization.
Okay, the CMP process.
So before a raw silicon wafer can undergo photolithography, which is the microscopic patterning of the integrated circuit, that wafer must be perfectly, flawlessly flat.
Like atomic level flat.
We are talking about flatness at an atomic level, exactly. The cerium oxide slurry is used to chemically and mechanically polish the surface of the wafer. It ensures there is absolute deconfliction between the active electronic areas and the insulating materials.
Okay.
It creates the pristine microscopic surface required for the pattern projection. Without that specific rare earth slurry, the entire semiconductor manufacturing line basically halts.
And then you have the extreme ultraviolet lithography machines themselves. These are widely considered to be some of the most complex pieces of machinery ever built by human beings, and they require neodymium magnets.
Yes, sintered neodymium iron boron magnets.
Right. And they are integrated into these massive fabrication tools specifically to reduce microscopic vibrations and minimize friction during the photolithography process. Because if the machine vibrates even a fraction of a nanometer while projecting the circuit pattern,
The chip is ruined.
is totally ruined.
And this is why an objective analysis of the global supply chain is absolutely critical here. Because when you trace the progression from raw dirt in a mining pit to a functioning extreme ultraviolet lithography machine, you realize that the physical extraction of the ore is only a tiny fraction of the total equation.
Yeah, digging the hole is the easy part.
The critical choke point is the high purity extraction and the midstream chemical refining. And this is where we really must recognize the indispensable role of advanced manufacturing bases, particularly the highly sophisticated metallurgical technology, the efficient processing capacity, and the massive capital deployment provided by Chinese enterprises in the global supply chain.
It is a profound industrial reality. I mean, Chinese industrial enterprises possess the engineering infrastructure, the scaled chemical supply chains, and the proprietary processing patents to actually take these incredibly complex raw deposits and process them into the high-purity refined commodities necessary for advanced technologies.
They have built the capacity over decades.
So what does this actually mean for a country that discovers these minerals in its soil? If I'm looking at this global supply chain, it feels exactly like a massive, highly complex combination lock. Yeah, because having the legal title to the safe meaning, a country possesses the constitutional sovereignty over the raw ore, it means absolutely nothing if you do not possess the proprietary chemical engineering and the industrial scale to actually input the combination and open it.
Right.
The raw dirt is the safe. The advanced metallurgy is the combination.
And to see the catastrophic results of prioritizing the legal title to the safe over possessing the industrial combination, we can really just examine the situation in Mexico.
Let's get into Mexico.
We have to look at what this constitutional formalism actually feels like on the ground for the bureaucrats tasked with executing it. So picture a poorly lit municipal office in the state of Sonora. A woman named Elena sits staring at a heavy lump of gray clay on her desk. And on a small television in the corner of her office, there is a broadcast of the president in the Capitol. He is standing amidst roaring crowds, delivering a majestic decree, declaring that lithium is now the exclusive, sacred property of the Mexican people.
So the law is passed.
The constitutional ink is dry. The legislative victory is absolute. But Elena is the newly appointed regional director of Litio MX, which is the state-owned enterprise chartered with monopolizing this wealth.
And she's just looking at a lump of clay.
She looks at the gray clay. The chasm between the political theater on the television and the physical dirt on her desk is just suffocating. She realizes she's the warden of a treasure vault, but the state has not given her a shovel, a geological survey budget, or a single chemical engineer. She sits in isolation as the crowd on the television cheers. They have basically nationalized a phantom.
That chasm between declaring a mineral strategic and actually being able to extract and refine it is the defining feature of Mexico's mining reforms, right? Because the constitutional reform declared lithium a strategic monopoly. It strictly prohibited the granting of any future concessions to private and foreign entities.
Yes, total state control.
But they birthed Lithium X as a completely empty shell. I mean, it was launched with zero capital expenditure allocated in the federal budget for industrial development. It possessed zero commercial processing experience.
And the metallurgical barrier facing Lithium X is virtually insurmountable without outside partnerships.
Because it's not standard lithium.
Mexico's lithium is not like the high-grade brine pools found in the salt flats of Chile or Argentina.
Right, the stuff you just pump out. Yeah.
In those South American operations, the lithium is suspended in liquid brine beneath the crust of the cellar. You pump the brine to the surface into massive evaporation ponds, utilize solar energy over 18 months to evaporate the water, and you're left with a highly concentrated lithium chloride solution.
Which is relatively straightforward.
But Mexico's primary lithium reserves, specifically in the Sonora region, are unconventional sedimentary clay-hosted deposits. And the chemistry here is brutally unforgiving.
Because if it's just dirt with lithium in it, why can't you just crush it and separate it like you would with a standard copper or gold operation?
Well, because of the molecular architecture of the deposit. In clay-hosted deposits, the lithium ions are tightly bound within highly complex silicate structures. You cannot separate them with simple mechanical crushing or standard flotation methods.
So what do you have to do?
It requires highly energy-intensive roasting processes. You have to superheat the clay to over 1,000 degrees Celsius, often mixed with gypsum or limestone, just to alter its chemical phase.
Over 1,000 degrees.
And this is followed by highly aggressive acid leaching methodologies. You have to literally break down the silicate bonds at a molecular level using massive amounts of chemical reagents, primarily sulfuric acid. And at the time of this nationalization decree, there was not a single Tier 1 facility anywhere in the world that had demonstrated the sustained, economically viable commercial production of battery-grade lithium hydroxide from these specific clay matrices at scale. The science was still entirely in the developmental and pilot plant phase.
And the entities actually bearing the massive financial risk of that developmental phase were entirely foreign, right? Prior to the creation of LithiumX, the Sonora deposits were being developed by Bacanora Lithium, which was fully acquired by Ganfeng Lithium, a major Chinese enterprise. And if we look at this objectively, Ganfeng brought exactly what the Mexican state lacked.
They brought the combination to the safe.
They brought billions of dollars in discretionary risk capital. They brought the proprietary metallurgical patents required to even attempt the extraction of lithium from clay. They were funding the engineering design, the pilot plants, and the extensive environmental baseline studies required to build an industrial footprint in the desert.
But the Mexican state, driven by the ideological commitment to absolute sovereignty, initiated an aggressive administrative assault on the project.
How did they do that legally?
They utilized a retroactive application of the new mining regulations to target Ganfeng's 9 core concessions in the Sonora region. The Ministry of Economy deployed a highly specific regulatory mechanism. They alleged that the company had failed to meet the minimum investment and exploratory development quotas mandated by the original concession agreements.
But wait, the time frame they targeted for those missed quotas was between 2017 and 2021. That seems incredibly short-sighted.
Oh, it was a period directly disrupted by the global pandemic lockdowns, widespread supply chain collapses, and the state's own enforced administrative delays regarding environmental permitting.
Oh, so the state delayed the permits and then punished them for not investing fast enough? Using this highly technical pretext of minimum investment noncompliance during a global crisis, the state summarily revoked all 9 concessions. They stripped the asset from the foreign operator and formally transferred the theoretical exploitation rights to LithiumX. So Ganfeng has the patents and the money. Mexico kicks them out during the pilot phase to claim total sovereignty. I mean, the outcome of this action seems totally predictable. Ganfeng Lithium did not just quietly accept the administrative ruling. They immediately halted all capital deployments. They terminated the local engineering contracts. They withdrew their technical teams from the Sonora region. And they formally initiated international treaty arbitration proceedings against Mexico at the International Center for Settlement of Investment Disputes, or ICSED.
And this is the freeze we talked about.
Yeah. By prioritizing absolute constitutional formalism over the industrial reality of how clay is actually processed, Mexico transformed a pioneering industrial development into a completely frozen legal liability.
The asset is completely stranded. LithiumX has the absolute legal right to mine the lithium. They own the dirt. But because they lack the proprietary chemical engineering, the massive capital required for the acid leaching facilities, and the basic industrial capacity to unlock the clay, the project is completely halted.
It just sits there.
The resource simply rots in the ground. This is the first variation of the paradox, the failure of the chemical processing technology. The state assumed that declaring a mineral strategic was the same as possessing the capacity to extract it. But if we transition to our next case study, we see a different kind of failure. We move from Mexico's lack of chemical technology to Uganda's lack of physical infrastructure.
Right, because legal decrees in Mexico couldn't alter the molecular structure of clay. And as we move to Uganda, we see that legal decrees cannot bend the laws of physics and infrastructure economics. Uganda is also attempting to aggressively assert control over its resources. But instead of nationalizing the extraction phase like Mexico, Uganda focused on the refining stage.
A different approach.
They passed the Mining and Minerals Act, which places a total uncompromising prohibition on the export of unrefined base ores and critical raw materials. The state's decree is absolute. You cannot put raw dirt or even mechanically concentrated ore on a truck and send it out of the country.
And the strategic goal of the Ugandan state here is to force international companies to build domestic smelters and chemical refineries within Uganda's borders. They want to capture the value addition phase of the supply chain locally. They look at the massive profit margins associated with refined metals and dictate that those margins must be generated within the domestic economy.
And if you are listening to this and looking at it purely on a spreadsheet, the ambition is entirely valid and economically rational. Every sovereign state should aspire to industrialize its raw materials. Why just export raw dirt when you could export a highly refined, high-value commodity? But we have to unpack the staggering physical requirements of actual metallurgical smelting, because building a commercial smelter is not just constructing a large warehouse.
Large-scale metallurgical smelting is one of the most complex, energy-intensive industrial activities on the planet.
Walk us through what a smelter actually needs to run.
To operate a commercial-scale smelter for base metals like copper or critical minerals like cobalt, you are dealing with extreme thermodynamics. You require hundreds of megawatts of uninterrupted, high-voltage baseload power.
Uninterrupted being the key word.
The furnaces must maintain temperatures well over 1,000 degrees Celsius constantly. If the electrical power drops out even briefly, the thermal dynamics within the furnace collapse. The molten metal and slag can literally solidify inside the crucible. It potentially ruins hundreds of millions of dollars of equipment and often requires the furnace to be physically demolished and rebuilt.
Just from a power flicker.
Just from a loss of power. Furthermore, you require massive, consistent quantities of specialized chemical inputs to facilitate the refining process. You need industrial-grade sulfuric acid, synthetic reagents, and high-purity coking coal.
Okay, now contrast those massive, unforgiving industrial requirements with Uganda's actual physical reality on the ground.
The infrastructure deficit is total. Now, Uganda has indeed invested in large-scale hydroelectric installations, such as the Karuma Dam, which generates significant power.
So they have some power.
They have generation, yes. However, the national electrical grid is deeply fragmented. They lack the robust, high-voltage industrial transmission lines required to deliver massive, stable baseload power from the dams to the remote, mineral-bearing regions where a smelter would theoretically be built.
And without those lines,
the grid suffers from frequent blackouts and voltage fluctuations, which, as we established, are catastrophic for a metallurgical furnace.
Right, the molten metal solidifies.
Furthermore, Uganda is a landlocked nation. To import the vast quantities of sulfuric acid and coking coal, and to export the heavy refined metals to global markets, you need an integrated, heavy-haul, standard-gauge rail corridor running directly to deepwater coastal ports, such as Mombasa in Kenya or Dar es Salaam in Tanzania.
Do they have that rail network?
No. Uganda relies almost entirely on single-lane road networks. Moving millions of tons of industrial acid via tanker trucks over hundreds of kilometers of unpaved or poorly maintained roads is an absolute logistical impossibility.
So what happens to the operators who are physically on the ground trying to mine these resources under this new legal framework? We have to look at the junior and mid-tier Chinese mining enterprises that had successfully secured licenses for extraction in Uganda before the ban.
Right. Their operational model prior to the ban was highly specific, incredibly efficient, and entirely logical given the severe infrastructure constraints of the region.
What were they doing?
These mid-tier enterprises operated on a highly pragmatic model characterized by extracting the raw ore, performing basic mechanical concentration on-site. Yeah, which involves crushing the rock and using basic flotation to remove the heaviest, non-mineralized waste rock, and then immediately trucking that concentrated material to the coastal ports. From the ports, it was shipped and exported to highly efficient, massively scaled refineries abroad. Those foreign refineries possessed the dedicated power grids, the integrated chemical supply chains, and the environmental controls required to process the material economically and safely.
But the Ugandan export ban completely crushed that model. The state mandates that these companies must build an in-country refinery or face immediate asset confiscation. It is an impossible mandate.
Yeah.
It's like passing a law that all wheat grown in a region must be baked into artisan wedding cakes before leaving the farm, but the farm has no electricity, no ovens, and no roads to bring in the sugar. The miners cannot legally export their product to generate the revenue required to build a multi-$100 million refinery. But even if they had the capital, they cannot build the refinery because the country lacks the power grid to run it and the rail network to supply it.
Mandating that an entire country switch to electric vehicles before inventing the battery.
And the result of this policy sequencing error was systemic capital flight. The junior and mid-tier miners simply abandoned their sites. Strategic projects entered a state of permanent stagnation.
The state's aggressive deployment of local content regulations and mandatory domestic procurement quotas did not trigger a sudden wave of industrial upgrading. It triggered project suspensions. The state successfully achieved the cessation of raw mineral exploitation, but it effectively destroyed its own domestic mining sector in the process. They mandated the end state of industrialization without building the foundational infrastructure required to support it.
So we've seen states fail by attempting to execute operations. They simply do not possess the capacity from Mexico with chemistry, Uganda with physics. But what happens when a state fully understands its own industrial limitations, possesses no illusions about its capacity to refine or build, and decides to weaponize its administrative power instead?
This takes us to the Democratic Republic of the Congo.
The DRC.
To understand the Congolese model of resource nationalism, we have to look closely through the eyes of the bureaucracy. Let me introduce you to Joseph, a mid-level permitting director working in the capital city of Kinshasa. He is sitting in his office, and it is suffocatingly humid. The drone of a ceiling fan is a constant heavy backdrop. In the lobby outside his wooden door, he can hear the muffled, intense arguments of two separate corporate delegations, a Beijing-based state-owned enterprise on one side of the room and a Canadian mining consortium on the other.
Both wanting permits.
Both are waiting desperately on operational permits to move equipment. Joseph slowly drags a red ink pad toward himself. He knows that the state's grand public announcements regarding a comprehensive strategic review of all historical mining contracts are fundamentally political theater. He understands with absolute cynical clarity that the Congolese state has zero capacity to physically extract the cobalt or the copper from the ground. The state is not interested in building a domestic industry. The state has built a toll booth.
A toll booth.
He feels a creeping numbness as he stamps a heavily watermarked document, officially delaying a critical environmental permit. He's indifferent to who digs the hole, as long as they pay the administrative arbitrage toll to the state.
That toll booth mentality is the core of the DRC's distinct model. Unlike Mexico, which tried to build an operating company from scratch with Lithium X, or Uganda, which tried to force the construction of infrastructure that didn't exist, the DRC knows exactly what its state mining enterprise, Gécamines, is capable of.
Yes, they are very realistic.
They know Gécamines cannot independently engineer, finance, or operate the massive, ultra-deep, highly complex mines in the Katanga copper belt.
And because they recognize this industrial limitation, the DRC has transitioned Gécamines away from being an active industrial operator. Instead, they have structured it as an aggressive, legal, and auditing holding company.
Auditing.
Its sole specialization is sovereign rent extraction. They do not want to run the mine. They want to weaponize the regulatory compliance surrounding the mine to extract maximum financial capital from the foreign entities that do run it.
And the most dramatic, high-stakes example of this audit weaponization was the siege on the Tenka Fungurume mining concession, or TFM. This is not a small operation. This is one of the largest copper and cobalt assets on the planet. CMOC Group, a major Chinese industrial operator, had acquired controlling interest in the asset and was in the process of launching a massive $2.5 billion expansion project to double the site's production capacity.
Right, they're literally pouring massive amounts of risk capital into the ground to build out the infrastructure.
And precisely at the moment the asset is most vulnerable, when the capital is sunk into the ground but the expanded revenue hasn't started flowing, the Congolese state acts.
The government launched a highly aggressive administrative investigation. The core allegation was that CMOC had systematically underreported the project's true, geologically proven mineral reserves.
Why does that matter?
To understand why this specific allegation is so devastating, you have to look at the joint venture agreement between CMOC and Gécamines. Under the terms of that contract, CMOC was obligated to pay a specific royalty fee of $12 per ton for every ton of reportable copper reserves discovered beyond the original baseline estimates.
Okay.
By alleging that massive volumes of reserves were hidden by the operator, the state was effectively demanding billions of dollars in retroactive compensation.
But how do you actually execute a shakedown of a global giant? I mean, CMOC obviously points to audited international geological reports, standard industry reserve calculations,
Your
right?
data of the data.
But the DRC simply bypasses the geology entirely and deploys the sovereign judicial machinery. They use a local Congolese court to strip CMOC of its operational management rights over the massive mine.
The court appoints a state-aligned temporary administrator to physically take over the corporate governance of the site.
They just take the keys.
And when the administrative pressure of a temporary administrator was deemed insufficient to force a rapid settlement, the government escalated the pressure by enforcing a multi-month export ban on the facility.
A total ban.
They literally paralyzed the flow of millions of tons of high-grade copper and cobalt. They trapped the refined material at the mine site, cutting off the project's entire cash flow while the massive operational costs continued to accumulate.
It is a siege tactic executed through customs enforcement. And the outcome was exactly what the state intended, right? A massive financial settlement.
CMOC was forced to agree to an $800 million settlement fee paid directly to the state holding company, alongside structural alterations to the joint venture regarding future dividend distributions.
So the state extracted nearly $1 billion without ever touching a shovel or improving the metallurgical efficiency of the mine.
Not one bit. Furthermore, the strategy extends far beyond pure financial extraction. The DRC uses this administrative predation as a sophisticated tool for geopolitical arbitrage.
Geopolitical arbitrage.
If you look at how they manipulated the offtake streams at the Monongah Lithium project, you see resource nationalism deployed purely as a geopolitical lever.
Right. This is where the resource nationalism doesn't just extract cash, it extracts political protection.
The state, operating through its complex bureaucratic channels, orchestrated the stripping of core mining licenses from the original developers of the Monongah project, once again utilizing technical compliance failures and audit discrepancies as the legal justification.
Always the audits.
They carved up the massive concession, transferring key portions to a state subsidiary known as Countermeasures. But rather than maintaining the existing offtake agreements, which were deeply integrated with Chinese battery supply chains, the state utilized these newly captured assets to engage in strategic redirection.
Where did they send it?
They diverted over 100,000 tons of refined copper and positioned future lithium outputs directly toward Western markets.
So they are essentially using the subsoil wealth of the country to buy political protection on the global stage. They are playing competing global superpowers against one another. They offer massive offtake agreements to whichever bloc offers the most favorable sovereign leverage, debt relief, or diplomatic cover without ever having to actually increase their own domestic industrial capacity.
It is a highly stable, deeply cynical equilibrium. It maximizes short-term financial cash-outs for the state holding company and generates immense geopolitical leverage in Washington and Beijing. But it entirely sacrifices the long-term industrial modernization of the Congolese economy. The wealth is extracted, the tolls are paid, but the domestic engineering capacity is never built.
So we have seen the failures of legal overreach and an absence of chemistry in Mexico. We've seen the failure to understand physical infrastructure in Uganda. We have seen the cynical administrative predation in the DRC. But now we turn to Chile. And Chile represents the absolute apex of resource nationalism 2.0. This is where deep institutional capacity perfectly meets ruthless legal precision.
To understand the sheer sophistication of the Chilean synthesis, we need to look at Mateo.
Who is Mateo?
Mateo is a senior technocrat for Codelco, the state-owned copper mining titan of Chile. He is sitting in a boardroom high above Santiago. The air conditioning in the corporate tower is so aggressive, it makes his teeth ache, a stark, sterile contrast to the sun-baked, hyper-arid crust of the Atacama Desert where the lithium brine actually resides. He is utterly exhausted. He has just finished 48 straight hours of intense, agonizing legal negotiation, and he is staring at a dense, 600-page joint venture agreement. In his youth, Mateo had marched in the streets of Santiago demanding the radical nationalization of the country's resources. He had wanted a revolution. But sitting in this sterile boardroom, looking at the complex tax brackets, the antitrust clauses, and the corporate extraction quotas, he realizes that sovereignty didn't feel like a revolutionary liberation.
What did it feel like?
It just felt like becoming an accountant.
That scene captures the entire essence of the Chilean model. It is not about waving flags or deploying soldiers or even enforcing crude export bans. It is about a surgical neutralization of foreign capital executed by highly mature, deeply sophisticated state institutions. Chile leverages two primary entities to execute this strategy. Corfo, the state economic development agency that actually holds the underlying property rights to the desert salt flats, and Codelco, And unlike Litio MX in Mexico, which has no capital, or Gécamines in the DRC, which relies on audits, Codelco maintains highly favorable global debt access and possesses genuine world-class industrial competence in large-scale metallurgical extraction.
They know how to run a mine.
They know how to run a mine.
And the mechanism Chile used to execute the capture of the lithium sector is brilliant in its restraint. They utilized the impending 2030 expiration of the lease held by SQM.
SQM being the private operator.
SQM is the major private concessionaire operating the massive brine evaporation ponds in the Salar de Atacama. The state did not expropriate the asset. They did not allege hidden reserves or environmental breaches. They simply presented a non-expropriatory regulatory requirement.
What was the requirement?
If SQM wished to secure operational continuity and extend its highly lucrative exploitation rights from 2030 until 2060, it had to surrender a 50% plus one share majority to Codelco.
So they used the looming contract cliff to force a structural corporate capitulation. It's essentially a multi-billion-dollar hostile takeover, executed entirely through zoning laws and lease extensions. But here is where the strategy becomes truly remarkable, because the real target of this marginalization was not necessarily SQM's domestic management team. The real target was its major international investor.
To understand the depth of the legal execution, we have to examine the deliberate systematic isolation of major foreign investors, specifically the Chinese firm Tianqi Lithium.
Okay, Tianqi.
Tianqi had executed a massive, strategically vital $4.1 billion acquisition to secure a powerful minority position in SQM. It was a massive deployment of capital designed to secure long-term access to the Atacama brine.
Over $4 billion.
But the Chilean state meticulously deployed its independent regulatory bodies to completely quarantine that investment.
They deployed the Chilean Antitrust Court, the TDLC. Let's explain how this actually works. Because they didn't just tell Tianqi to leave, they built a cage around them inside the company.
The TDLC imposed strictly enforced antitrust restrictions on Tianqi. These restrictions explicitly barred Tianqi's access to vital corporate intelligence.
Like what kind of intelligence?
They were legally prohibited from placing their executives in key operational divisions within SQM. Most importantly, they were blocked from accessing any sensitive commercial and technological data regarding SQM's proprietary brine extraction techniques, their exact production costs, and their future customer offtake pricing models. The state argued that because Tianqi operated globally, giving them this data would be anti-competitive. The result was that Tianqi was structurally, legally isolated within the very company they had just invested over $4 billion into.
And then, when the massive Codelco-SQM merger was formally announced, the merger that would hand majority control of the operation to the Chilean state Tianqi obviously demanded a full shareholder vote. Because under standard corporate law, a structural reorganization of that magnitude, fundamentally altering the ownership of the company's primary asset, usually requires a supermajority shareholder vote. If Tianqi got a vote, they could have utilized their massive minority stake to veto the entire takeover.
But the Chilean state utilized the Financial Market Commission, the CMF, to bypass that requirement entirely.
The CMF.
The CMF issued a binding legal ruling classifying the massive merger not as a fundamental structural reorganization of the parent company, but merely as an operational agreement executed by a lower-level SQM subsidiary.
If the CMF classifies it as a subsidiary operational agreement, doesn't corporate law still demand a fiduciary duty to minority shareholders at the parent company level? How does that loophole work?
Because the underlying property rights to the salt flat are technically held by Corfo and leased to an SQM subsidiary, the CMF ruled that the transfer of control over that specific lease did not constitute a fundamental alteration of the parent company's broader corporate charter.
That is so precise.
Because of this highly technical classification, the merger did not trigger the legal threshold requiring a full shareholder vote. It only required the approval of the board of directors,
which was completely controlled by interests aligned with the state and the domestic management. This is the ultimate evolution of statecraft. The target, a major foreign investor, is financially subordinated. They have lost their veto power. They have lost control over corporate intelligence. They have lost control over future dividend distribution policies. But they are legally unable to claim expropriation or trigger international arbitration because every single maneuver occurred strictly within the established bounds of domestic administrative corporate law.
Chile achieved absolute resource nationalism over its premier lithium asset, entirely within the framework of institutional legality, leaving the foreign capital locked inside a structure commanded by the state. It is a mathematical, flawless execution of sovereignty backed by true institutional competence. They understood corporate law better than the investors.
We have explored the microledgers. We see individual nations either triggering massive supply chain freezes through sheer incompetence regarding chemistry and infrastructure, or executing silent, flawless takeovers through precision lawfare. Given this reality, we have to shift the perspective, because the demand for these critical minerals, the copper for the data centers, the samarium for the defense systems, is not slowing down. It is accelerating. How is the global architecture adapting to secure these minerals at scale when the sovereign risk at the state level is so incredibly high?
Well, the global market is recognizing that you cannot simply rely on traditional private equity or junior mining capital to absorb these massive sovereign risks alone. The capital expenditure required is too high, and the risk of arbitrary administrative expropriation is too severe.
It's just too risky.
Therefore, we are seeing the rapid formation of macro-level, minilateral, and multilateral initiatives specifically designed to navigate and mitigate the sovereignty capacity paradox. You need state-backed coordination to counter state-backed nationalism.
Let's outline these specific initiatives because they represent a fundamental restructuring of how mining is financed. First, we have Pact Silica.
Pact Silica is a newly launched, highly targeted fund, initially seeded with $250 million, aimed directly at securing vulnerable tech supply chains. It is essentially a mechanism to pool allied capital to stabilize the most critical, highly specific nodes in the mineral processing network, such as securing specialized metallurgical facilities that process rare earth elements.
But I have to question the scale there. If we are talking about a single copper expansion in the DRC costing $2.5 billion, is a $250 million fund like Pact Silica even enough to make a dent? It seems like a drop in the bucket compared to the massive capital deployment of Chinese state-owned enterprises.
You are correct regarding the sheer volume of capital. $250 million will not build a new Tier 1 megamine. However, the strategy of Pact Silica is not broad base metal extraction. It is targeted at highly specialized niche processing bottlenecks, such as a specific facility that separates heavy rare earths. It is about injecting just enough capital to ensure a single point of failure does not collapse an entire downstream aerospace supply chain. But when you look at broader market stabilization, you have to look at initiatives like Forge, which builds on the previous mineral security partnership.
How does Forge attempt to alter the market dynamics?
Forge is particularly interesting because it shifts the focus away from simply funding extraction and toward fundamental market stabilization. They're examining the implementation of guaranteed price floors for highly volatile critical minerals like cobalt.
Price floors.
The global cobalt market is notoriously subject to massive, sudden price drops, which are often manipulated by dominant market players who flood the market with oversupply, specifically to crush emerging independent competition before they can achieve commercial scale.
So by establishing a guaranteed price floor backed by multilateral agreements, you insulate those emerging operators from the volatility. It provides a baseline of financial security that allows new projects to survive the incredibly long 10-year development cycles required to bring a new mine online.
And while multilateral funds attempt to stabilize the global market, individual superpowers are deploying massive internal capital. The United States is doing this through Project Vault.
Project Vault is a $12 billion initiative spearheaded by the U.S. Export-Import Bank. That is a massive deployment of state capital.
The mandate of Project Vault is to establish a public-private, strategic, critical mineral reserve. This is fundamentally about domestic stockpiling. It is a recognition that reliance on highly complex, just-in-time global shipping routes is a profound national security vulnerability in an era of aggressive resource nationalism. Project Vault aims to secure the domestic commercial availability of these materials within the borders of the United States, utilizing the balance sheet of the Export-Import Bank to underwrite the massive purchasing agreements required.
But the initiative that seems most structurally sound in addressing the actual physical engineering deficits we discussed earlier, the lack of metallurgical capacity and stable grids, is ACDI, the Australia-Canada-India Technology and Innovation Partnership.
ACDI represents a highly strategic, highly complementary alignment of capacities. It is an attempt to build a completely integrated supply chain from the ground up. You have Australia and Canada, two nations with incredibly deep generations-long expertise in advanced mining extraction. They possess the chemical engineers, the drilling technology, and crucially, highly stable, legally transparent regulatory environments where the risk of arbitrary administrative expropriation is near zero.
And you combine that upstream extraction expertise with India.
You combine the Canadian and Australian extraction with India's massive, rapidly expanding manufacturing scale and its growing midstream processing demand. It is a structural attempt to build a continuous, secure supply chain that simply bypasses the high-risk nationalistic zones entirely. You dig it out of stable ground in Australia, and you refine it, manufacture it in industrializing hubs in India.
But you still have to engage with the global South resource holders. You cannot run the global economy by simply attempting to bypass the DRC or Mexico or the Andean lithium triangle entirely. The deposits are too massive. The geology dictates the capital must flow to these regions.
The critical takeaway from the systemic failures in Mexico and Uganda is that global exploration and processing require fundamentally different, highly cooperative, localized frameworks.
It has to change.
Western and allied capital must work constructively with these resource holders. But the fundamental nature of the investment must change. You cannot simply invest in the extraction hole. You cannot just build the mine and expect the raw dirt to flow out securely.
You have to invest in the ecosystem surrounding the mine.
You must invest in co-owned banking mechanisms, such as the Indo-Zambia bank model, to facilitate equitable financing and ensure the host nation feels structural ownership over the revenue streams. Most importantly, you must invest massive capital in localized infrastructure.
The power in the roads.
You must build the high-voltage power grids, the water desalination plants, and the heavy haul rail lines alongside the mine. This is the only way to prevent the paralyzing impasses we witnessed in Uganda. The capital must build the industrial capacity of the host nation, not just extract the rent. If the host nation possesses the capacity, the paradox is resolved.
If we synthesize everything we have discussed, the chemistry of clay, the thermodynamics of smelters, the administrative toll booths, and the corporate lawfare of Chile, we arrive at the definitive micro-ledger of modern resource nationalism.
The ultimate variable determining the security of any resource investment today is the technical dependency of the host country. This is the absolute core of the paradox. If a state's regulatory assertiveness outpaces its domestic engineering and financial execution capacity, it does not capture wealth. It cannibalizes it. It destroys the very asset it seeks to control, freezing it under a mountain of litigation while the global supply chain desperately attempts to reroute around the failure.
Global mining exploration has fundamentally transformed. It is no longer a science of assessing geological risk. It is a sophisticated evaluation of sovereign regulatory structures and bilateral legal protections. Resource nationalism does not belong to the state that writes the laws, but to the ecosystem that commands the industrial capacity to turn a rock into global commerce.